So hey guys, we're back. For this video, we're going to tackle Chapter 6 Network Layer. The previous video, we have a summary, and now for Chapter 6, we're going to have a summary of Chapter 6 Network Layer, entitled Network Layer. So in Network Layer, we have different objectives like network layer protocols, network layer, and protocols. And for protocols, we have IPv4 and IPv6. And yeah, so proceed. In network layer protocols. Actually, guys, in the past, last video in chapter 5, inside the chapter 5, the data links, these two data links, and physical are the types of the exchange of data, terms or the process. Here inside the chapter 6, we're going to tackle all the 6 layers on how they transfer data. First, this is a uh, IP address, addressing. So let's name this PC1, being transported or delivering the message to laptop 1. Okay, process is ongoing from application, presentation session, in transport. So it's encapsulated to segment, encapsulated again to packets in a data link, encapsulated again into a physical, so that frame physical number, which is this the binary number as a device or a computer language. After that, it passes through, excuse me, it passes through a modems or switches or servers, encapsulated until it reaches the host with a particular data that has been transferred from PC1. So also, network layers, it focuses on the role of the network. It examines the device and the network in groups of hosts to manage the data. It also covers the communication and network, and those covers means it or sometimes it is called routing, like communication network. Sometimes they're called routing. Explain further more about routing later. Okay, so that's network layer, guys. These 7 layers are on how they transfer or how they pass the message or data from host one to host two. It can be transferred to the use of different medium like mm, we have cables, fiber optic. We have different kinds. What else? Uh, crossover or phone. We have different kinds of mediums. Okay, and every layer has its role or has its process on how it breaks down the data, and or in some other terms, in some other terms, it's a process on how they encapsulate and decapsulate. Next, so we have protocols. 2 protocols to be exact: the IPv6 and the IPv4 and the IPv6. As you can see, guys, this is the packet. This is the packet of IPv4. Of course, we need to be familiar about what is the version or the total length, the source IP address or the 192.1. Yeah, and the destination IP address where it's going to, then time to live, because you don't want those nasty or unlonging packets inside, or or existing or non usable packets inside your network. So you should have the or you should set its time to live, or like, mm, after it delivers it disappears, or it destroys itself. As you can see, guys, this is the first uh, version of packet tracer. Packet, or the protocols, the internet protocol, version 4, the IPv4. In IPv4, guys, here, this is the uh, header, or the packet itself. Should be familiarized also. And the reason why the uh, IP version 4 or IP version 4 is being phased out or not using anymore, because as of now, the depletion of IP address is IP address for version 4 IPv4 is being deducted already. There are no there it lacks the IPv4 also lacks the end-to-end connectivity, unlike the IPv6. It's so lengthy, and it has a lot of familiarization about its packet. That is why the IPv4 is being phased out and depicted. Being depicted. But as of now, there are still people or connection or network that are using IPv4. Yeah. Next, for IPv6, if you're going to ask me, I don't know why there is no IPv5. Probably um, there is, but I guess there are kind of problems. I don't know. But IPv4 and IPv6 are the two protocols. Here, guys, in IPv4, IPv6, in this version, it increased the address space. So, what is address space? Address space is the 192.1 blah 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 dot. So it increases the space of a version. Here, it's hidden here. Are based on a 128-bit hierarchical addressing, as opposed to one by IPv4 with 32 bits. So the bits, guys, its size. So in IPv4, the size of IPv4 is 32 bits, and it increased from probably 90 something bits per second in IPv6. Also, guys, it improved the packet handling. It eliminates the need of NAT or network address translation tables. Also, it can be used for different devices, not only for laptop, but IPv6 can be used by the different devices. So actually, it is more efficient. It is more simplified. The header itself, and I said that a while ago earlier. Every device can use the IPv6. So actually, guys, this is the actual header of a packet IPv6. Wait, it's loading. I don't know why. Here, sorry Ah, this is the actual packet header. Unlike the packet header of IPv4, the v4. It's lengthy, a lot of process, a lot of memorization, but here it's efficient, it's precise. Also, they have the of course also the IP address, source IP address, destination IP address. The V6 guys is like every if you develop something, you always aim for people to be more to handle it easier, to have more to have less boundaries on how to use its capabilities. Here in IPv6, it has a lot of I mean it has uh, let's say slight boundaries or a big difference than IPv4. But actually, um, this time we are still using the IPv4. Probably some companies are still using the IPv4, and in IPv6 they tend to combine or encapsulate each other. So more of a what you call this protocol type combination, like here. Oh, it's not here. Here, guys, I'm telling you the IP encapsulating or the both IP protocols. Here, connectionless, best effort, and media independent. Here, guys, to explain it to you easier, connectionless is like the I am the receiver and you are the sender. Delivered me a mail, for example, a mail, and I don't even know or I don't have any idea that I received the mail. For example, a mailman delivered a mail to you and you yourself don't even know that you've already received the email or the mail. So that is connectionless. There is no connection. If there is a connection, right before it delivered, if right before it delivers the mail or the email, you yourself already know that this day or this time I shall or I will receive an email. So in that part, it has a connection. It connectionless because you don't even know if you or when will you receive a mail or a information or data. Next is best effort. For example, you searched a particular information like how to cook this bulalo. It gives you the best effort on okay, this is only what I can give to you, the menu, but there's only what I can give to you with this location of site. That this is the best that I can give you. That's it. They can't find any more much better uh, process on how to cook. This is what I give to you. That's the best that I can give to you. That's the best effort. It's written here. IP is inherently unavailable because packet delivery is not guaranteed. That's what I earlier explained. It is what they can only give to you. All right, that is the best effort. This is what they can only give to you. Next, the media independent. It can travel over different types of media like copper, wires, fiber optics. So hey guys, okay, now let's proceed in routing. Where's that? Here. Before guys, I'll be telling you there are three types of destination. So we have itself, the local host, and the remote host. So if it in itself, it's going to be like, am I going to deliver a, for example, I'm a router. Am I going to deliver a message to me or my IP address? That's itself. Localhost here. Where's that? Inside the local host. This one. From that number covering this circle until it reaches that point. That's a local host. It delivers a data that who or what is connected inside the local host. And the remote host is a host on a remote network. Hosts do not share the same network address. Another term, mm, yeah, it is independent. It doesn't share any other network addresses or address or unlike the local host, it has a uh, what do you call this? It has a similar local host. I mean, local host. It has has a similar network address because it is connected to a one switch or one router. Um, sorry. Also, guys, here in the router, there is a default gateway. So, what is default gateway? Can take data in and out of the system. Like mm, it routes traffic to other networks. It has a local IP address in the same address range as other hosts on the network. Can take the data and forward the data out. That's it. Can take data in and forward the data out. So that is the default gateway. Probably the default gateway is if you watched the previous summary, default gateway is similar to its IP address. That is the default gateway. Routers. So actually, guys, there are different types of routers. So we have here branch, one, service provider. Yeah, that is those are the different servers or routers, service routers. In one, we have the large business or organization and enterprises, like example, the Octagon in America. It is large. It has a lot of routers, and they have lots of servers and how they store and delivers data. Branch, telework, small business. Here is like what do you call branch? Mm, probably a computer shop type thing that has lots of teleworks and small business. And in computer shop is a type of a small business. In a service provider here, large service providers including Cisco, ASR, Cisco, CRS, Carrier. Uh, Probably it is a higher end router than the other remaining two routers. So, yeah, so that's it for my chapter 6 summary, network layer. Thank you, guys.